All right, so this is still 8.1. We're defining and using sequences and series. This is video number 2. We're going to write some rules for some sequences. Okay, so we need to describe the pattern, write the next term, and then write a rule for the nth term. So when we're describing the pattern, we have two different ways to describe it. And let me get something else to write on here. Okay, oops. So we have, and you can add this to your vocabulary or write it somewhere, you're either going to have an arithmetic sequence or you're going to have a geometric. That's the description Big Ideas is wanting. Which one is it? Well, we're not actually going to cover these until 8.2 and 8.3. That's when we get into depth with these types of sequences and series. But when we're defining them, this is just if you add or subtract to get to the next term. And it's geometric if you multiply or divide to get to the next term. Okay? So that's how we're going to describe the pattern. We're either going to say it's arithmetic or geometric or neither. Okay? So let's start with number 3 in the notes. So we want to figure out what's going on from one term to the next. And so what I like to do is draw a little table here, and so my n will be on top, an is going to be on the bottom. An is the term itself, so -1, -8, -27, and -64. Okay, obviously we keep going, but I don't need to write that much. And n is 1, 2, 3, 4. It's the first term, second term, third term, fourth term. That's what n is. Okay? And let's figure out what we're doing to get from one term to the next. Well, if I am trying to see if I am adding, well, it's -8 minus -1. Well, it added a negative, it added a -7. Well, it added a -19 to get to the next one. So it's not arithmetic. Multiplying to get from -1 to -8, it multiplies by 8. But -8 times 8 would be a -64. So it's not geometric. So we're actually going to say this one is neither. That's how we're going to categorize it. But we need to figure out what's actually happening here. And I can see a kind of a pattern. If I look closely, I can see that 1 is the same thing as saying 1 cubed. 2 cubed is +8. 3 cubed is 27. 4 cubed is 64. So you can try to figure out if things are powers of each other, just from different functions we've used throughout the year. And so I can see that whatever this number is, if I cube it, I get this, but then I get the negative of it. Well, cubing, I can have my number be negative. -1 cubed is -1. -2 cubed is -3. So the next term here, I would have a 5th term. Well, -5 cubed would be -125. Okay, so my a to the 5th, which is my 5th term, is going to be a -125. And then I figured out that my rule, so I'm going to write a rule, and I'm going to say, okay, an, so no matter what n is, this is the rule that'll help me find that number. And I said if we take n and we cube it, we're going to get these numbers, except these are negative. So I need to make n negative. -n cubed gets me all of this. So there are my rules. So all of this are answers that it needed. All right? So let's try this again. So it may take some guess and check for you to figure out which, or figure out the rule for it. And I realize I didn't give myself a terrible amount of space on this. So let me get another little piece of paper here. I just think I'm going to write a little bigger than what I have space for. All right, so if I write my table, I have n and I have an. So 1, 2, 3, 4 terms, 0, 2, 6, and 12. Okay, so here's another way to tell if it's arithmetic. If I find the difference between the two, which means 2 minus 0, okay, or what am I doing? I'm adding 2, okay? Here I add 4. Here I add 6, okay? Well, those aren't all the same, so I know it's not arithmetic, or I know it's not linear. That's what we're trying to determine here. Well, let's find the differences of my differences here, because then I see a pattern here. I see a plus 2, and I see a plus 2. That's very helpful. Okay? If the first differences, which is what we found right here, are all, if they were the same, this would be linear. This would be in a linear equation and arithmetic, okay? And I can write a linear equation easy. Remember, it's like y equals mx plus b. Whatever it's going up by is what you would multiply x by, and you would just add or subtract a number to get that first term. But this one's not linear, because they aren't all the same. But these are all the same, so this is actually going to be a quadratic equation. So I know I'm going to have n being squared. And then I really should have left myself some space here. So what I'm now going to do is write a new table, with n squared, just because I want to see, okay, I know things are going to be squared, so I want to see what happens, okay? So I have 1 squared. If n is squared, that one's 4. If that's squared, let's see, that'd be 9, and then 16. But my terms are still going to stay the same. So an is still going to say 0, 2, 6, and 12. So let's see now if I can see a pattern here. Let's see. Well, 1 minus 1 is 0. 4 minus 2 is 2. 9 minus 3 is 6. 16 minus 4 is 12. What I'm subtracting keeps going down by 1, like my n's here. N, or 1 minus 1 is 0. 4 minus 2 is 2. 9 minus 3 is 6. So I am seeing the pattern. If I take this number and I subtract this number, I'm going to get the number I want. Okay? So if I write this out as a rule, when I jumped ahead, I know we haven't described the pattern or written the next term yet, but I'm seeing the pattern, so I'm going to go ahead and write it out while I'm thinking about it. If I take n squared, which was my 1, so I'm going to write it, since we're writing a rule, we write this term here. So I'm going to say n squared. And I subtract this number, which is n, then I get my an. So that still worked here. 4 minus the 2 was 2. 9 minus 3 was 6. 16 minus 4 was 12. So you just have to look for the patterns in these and then see how it can work as writing it as an equation. All right, so looking at this, I can tell right away it's not arithmetic. I'm not multiplying by the same number each time, because I'd have to, 0 times anything is still 0. So it's not geometric. I can't add the same term we determined right here. That is not arithmetic. So we would say this one was neither. That would be how we would describe the pattern. The next term, okay, n would be 5. So 5 squared is 25, minus 5 is 20. So a to the 5 would be 20. And then our rule we came up with by figuring out that it's geometric. No, it's not geometric, it's quadratic. And then looking at what those numbers do, okay? All right, let's try it for number 5. Okay, well, we see our pattern here, see what's going on. If I list them in a table here, so I'll have n over an. So I have 1 is 2 over 5. Term 2 is 4 over 5. Term 3 is 6 over 5. Term 7 is 8 over 5. I can kind of see a pattern. Did I say term 7? Oh my goodness. I was counting 6, 7, get it? Okay, this is actually term 4, sorry. And if I keep going and want term 5, I can see that my bottom, no matter what, I know it's going to be a 5 on the bottom, because they all had 5, right? And 2, 4, 6, 8, ooh, that's going to be a 10. So I already know the 5th term is 10/5. Let's figure out if it's arithmetic. So remember, if I can add the same thing to each term, it's arithmetic. So let's see, 2/5 plus 2/5 is 4/5. 4/5 plus 2/5 is 6/5. And 6/5 plus 2/5 is 8/5. So I know, and again, if I would continue my 5th term. So these are all the same, which means this is a linear equation, and therefore it is arithmetic. Okay? Remember, if I add or subtract the same number to each term to get the next term, that's arithmetic. If I multiply or divide by the same term each time, that's geometric. Okay? And if that's not the case in either term, then it's neither. All right. So we need to write our rule. Well, let's see. So I'm going to have an AN equals, well, all of them have 5 on the bottom. So I know I have to have 5 on the bottom in my rule. Okay. So let's see, how did 1 become 2? How did N become 2, 4, 3, 8? It looks to me like if I take whatever value N is and times it by 2, I get that top number. 4 times 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. That's how I see it. So if I take 2 times N, and then it's over 5, I get my rule. So you can write it like this, or you could write it as AN equals 2/5 N. Both of these are correct. It doesn't matter which way you write it. So our 5th term is 10/5. This is arithmetic. And there is our rule. All right, so a lot of these are guess and check and trying things out. I want you to go to the practice and do numbers 16, 17, 20, 23, and 28, and then move on to the next video.